Hi guys, I welcome you here today also with this video now. I hope you guys are doing great. Everything else is going well. If you are watching this, I know you guys are completing 12 chapters of your class 9 mathematics. I hope you are not having any trouble in any chapters. If you are having, just revert back to those. If you are here now, that means you are ready to go with the next chapter now. You are on learning new, right? Learning new things every day. Keeping that attitude up, you guys, I'm back with this video. We are doing our mensuration part. So set up, I have this chapter here with you. It is your surface area and volumes. It is one of those chapters constitute maximum marks and is one of the easiest chapters, but it can be tricky as well at the same time. Remember this, it is easy. When I say this is easy, trust me guys, this is not that much tough. But again, if you are not applying particular logics here, if you are just doing any sum absent-mindedly, so you guys will be getting that wrong. This chapter will be, I will be covering this chapter into separate parts. Firstly, we will be covering up our surface areas, then we will be covering our volumes. What I will be going for is, I will be describing surface areas of figure. Then, while I've covered each and every figure and their surface areas, then I will be going on to volumes. I won't be keeping both of those surface areas and volumes simultaneously. I will be following your pattern of HRT. I will be firstly just doing entire surface areas. Then I will be shifting towards what I can also do it in other way. I can do this. I can pick a particular shape. Let's say I pick a cuboid. What I do is I just tell you guys that I will be considering what I will be considering their surface area and volume, doing each and every sum related to your cubes and cuboids. Then shift to our another figure. Let's say cylinder. Here we will also do what surface area and volumes, then to next and then to next. I can do either of that or the previous method, but I prefer if you guys just do this, firstly learn surface areas of, then you move on to your volume. Volumes are easy, you guys won't be having any trouble in doing. The trickiest part is the surface area. I will be explaining it how the surface areas are considered, what are surface areas and what are volumes, and what is the difference between. Starting with this, I hope you guys are not bored. Starting with the video, again remember this is a mensuration part. You have to calculate each and everything. Please don't use calculators. I will be telling you certain shorthand tricks here where you can follow those and make your calculations easier. If you guys already know certain tricks, then do let me know also where I can improve. We are all here studying together. That does not mean I have to just keep and you guys just have to put everything down. If you have any, you can tell me. Without wasting your time any further, I'll start with my video now. So the video is surface area and volume the chapter. This is the video one of this chapter. I might not be able to complete this entire chapter in one video. It might be broken down into more than two videos or so. Starting with our first video, this is our first one. So the basics. Now I have my introduction here. See, anything around us can either be or 3D. That depends on the face that we are looking or the position that we are looking at from. Let's say I am just looking, you're looking at your screens, at your what you see is your screen which is having a lens, and at a given time if you're only able to see at one face of a given figure, that is what that is your, or you can say anything that you can see but you cannot exactly touch that. Let's say actually not the touch box. Let's say anything which you can see at either on the top side or the bottom side, but at any given position you get only its one face. Like if you guys are seeing, cannot see the backside of either your phone or laptops or your tablets, whatever you are on, you can only see its screen. Want to see its back, then you have to flip that. Again, if you are looking at back, you cannot see its front face. The face that you are currently looking, that is your 2D face. Now, 2D figures are generally what? They are generally on your papers. You can say you can look at look at them from any top view or bottom view or any side view. Any particular face that you can see at a given time, that must be a 2D. But let's say I consider this figure. Now, if you guys look at firstly this field, if you look at this field, if you're looking from side, then top layer green at from the top, you can see is an entire space having greenery in that. If you look at this from top, what you see is a length and a width and the total area. So that is what that here figures. So generally it is categorized like this. Figures are actually drawn on paper, mostly drawn on paper, but you can see them in reality. But if you see this figure, the field, you see this field from your side view. Let's say if you see it from your this side, guys will be see the crops are standing in this field, like crops are standing. So it has a height, it has a length, and any figure that has three dimensions, okay, three coordinates, that must be a 2D. Like if I have this field and I say I'm standing at this point, let's say I part this and I have only which axis? I have my x and y axis, two axes here. But if I consider this figure, now this point, but your length, width, and height. Any figure which has three coordinates, that is your x coordinate, y coordinate, and z coordinate. If you plot this according to its three dimensions, that is what your 3D figures are generally those figures which you can hold in your hands also. If I tell you to just hold the field in your hand, can you hold it? Cannot, because it's a field. But if I tell you to hold a pencil box in your hand, you can hold it. Anything that can be held in your hands, it is what your 3D figure. If you guys draw a rectangle on paper, cannot hold it. It is a 2D figure. But what if I tell you, pick that rectangle up, or you can say just pick your paper up, cut out that rectangle and draw similar six rectangles more and join them. You're getting a what cuboid, and you can hold that cuboid in your hand. Anything that can be held in hand is your three-dimensional. A three-dimensional figure has what? It has faces. It has many faces, and each face has a separate area. I know how is this might be confused, but let's say I tell you this. Let's say I consider my this point. I know it has a top view. Similarly, its bottom part will also be congruent, so it must be having a bottom view. It has a side view also, right? And similarly, its back portion, that side will also be congruent. It will be having a side view, and this is its right view, left view. Now you see, at each and every viewpoint, you get a particular area. I will be having an area of this portion also. I will be having an area of this portion will also occupy area. Similarly, this will occupy, and that will, and the bottom one will also. So what happens here is a three-dimensional figure has many faces and it has area of each thing. So in order to calculate the area of any three figure, we call it simple surface areas. How we do it? Just calculate area of each. Then we just add them and we end up having two types of area. One will be my total area and another one will be my lateral, or you can say curved. Curved can be happening when we have a curved figure, considering we have a cylinder, we have here, etc. And lateral surface area will be only those figures that have straight lines. Only the case of cube and cuboid, the curved surface area called, actually they will be having a lateral surface, and other figures will be having a curved surface area total. Terms exactly mean difference here. Lines will be straight in circle, and lines there will be no line. There will be. Starting with this, I have types of 3D figures. Firstly, I have cuboid. Cuboid is what? It is nothing but six rectangles. When you join six rectangles, particular order, the top side congruent to your bottom side, your left side congruent to your right side, the front side congruent to your back side. If you get six rectangles, two of opposite rectangles are congruent to each, that figure will be forming a cuboid. But I'm trying to tell you, if you take two rectangles which are congruent to each other, take another two which are congruent to each other but not to the ones, and you take another two which are not congruent to before ones. What you get here is you join those figures as per their opposite faces. That's what it means. This face must be congruent to the bottom face. Top must be congruent to bottom. Right here. Top must be congruent to bottom. Left must be congruent to right. And front must be congruent. Count this 1, 2, first and 6. We have what? We have 6 faces here. Face will have its sorry. Each face will have its own area. Just remember this. Your cuboid must be having these three conditions here. Know this. Your left face must not be congruent with your top face. Neither of the faces which are opposite to each other, no, or I can say this, no adjacent face can be adjacent. No pair of adjacent congruent. If they are congruent to each other, the figure formed will be what a cube has 6. So in rectangle you have length and breadth. That is the case of want to find out area of any rectangle. But in case of 3D figures, explaining later on, one dimension will be your length, this dimension will be breadth, and this dimension. It will be having 3 dimensions. If I give you a live example of cuboid, guys must be sitting in a room, right? Guys always and guys have rooms, right? You have if you guys just look at any corner, either on the top from the top or the bottom, any corner, look at your any corner, you will be seeing a vertex there, that is the point where the three lines are meeting. First one will be your line which is either going from the right or left. Another one will be like that one. Let's see what I'm trying to tell you. This is your figure. Yeah, I have it. Let's say this is the point. Now you guys see, this is your zoom and this is the point here. This x is present, this x is present. Your zoom is what it is, 3D figure. But you look at your any wall. If you look at any given wall, let's say you look at your wall which has a TV on it, LEDs are on it. You look at that wall. Now you can see only one face, but it is nothing but a 2D angle. Remember this, if you can only see one face of any figure, that is a 2D figure. Like it is a rectangle, you cannot just hold your wall in your hands. It's fixed there, right? But you can see for the case of room also, but you guys see end up having a box-like structure, that is a 3D figure. You just look at any figure and it is a rectangle or whatever it has. If it has dimensions, that must be a 2D. Now in case of, remember this, your cube has 6 squares. That means face is equal to the other face. Every face will share the same area. I will be later on how its surface area found out. Let's see. I have now cone. Cone is what? Cone is a hat. You can say it that what it truly. You just have a circle, tension it, and you extend it. Take the center, and you just keep stretching towards your other end. End up having a triangular shape at the top and a circular bottom. What it exactly is, it's a circle attached to three different triangles. I will be explaining it to you later on how this is. Now you have your sphere, any 3D circle. Take your circle in 3D, you end up having a sphere, like your ball. Like ball is what? It is a 3D circle. Anything that you can hold, any circle that you can hold in your hands, it is what it is. And hemisphere is what? Hemisphere is the half of our Earth is also a spheroid. Like you can say moon is also sphere. Particularly anything which is round and is foldable and it is occupying certain area. That is what it is only on paper. It is a 2D figure. It is physical. But when it is taken out from that, it is held in hand. It is like I might have said something. I will be explaining how cone. Let's just that one. Now, starting with the surface area. Surface area, I've already told you. The surface area is of all possible. If you can see any face, then its area must be counted in the total. I will be considering certain scenarios here. Let me get to that point first. For you now, total surface area is the surface area of all possible faces that can be viewed from any given side. Understood? Now I have this. I have curved surface area. Curved or lateral surface area. Now see what is this. This is the area excluding any given face, or you can say particularly lateral surface area is what is the surface area which does not have any top or bottom face. If you don't want to consider the top or any bottom face of any figure, any 3D figure, what you have is a lateral surface area. Remember this, lateral or curved surface areas do not have top or bottom. Let's say I have what? Uh, let's say I have a pipe which my water is supplied. Now you guys see it does not have any top or bottom. It is open at both ends. Its area will be counted which one? Its curved surface. But here is a catch. Pipe will be having certain thickness. On this kind of sums also, there is a catch here. We will be doing certain sums which are not in your NCRT, but are the important ones this chapter has to offer. For this chapter is quite lengthy. Is quite lengthy, very vast. It has various kind of questions that can be asked or that have been one of those chapters which you if understand right now, then you won't be having troubles in your class 10. But if you don't understand this now, you will be surely having many problems. Chapter surface area volume same as in your class 10. There is another chapter based on this, but it is a bit advanced. So remember this, if you guys not learn it here, be facing problems. I remind you, understand each and everything. I will be explaining it to you how each formula is derived. So don't worry, you don't have to learn anything. You have to understand everything. Right? Let's see our volumes. Volumes is what? It is the total capacity. If I have a room, now see, you guys are sitting in your. You can fill your rooms with either clothes, furniture, air is already occupied in that. Any that can hold something in it, that must be volume. The maximum capacity of anything that can be held in a given 3D figure. Remember this, there is no volume for 2D figures. If somebody asks you, find the volume of a rectangle, simply there is no volume for that because volume requires a height. It is what it is. This area multiplied by its the maximum area that it can occupy, maximum height it can go. You guys are putting, let's say I give you an example. Let's say you have a cylindrical, let's say you guys have seen that crayon box. It was a cylindrical box which had a plastic lid on it, and it had cylindrical crayons in it. You guys remember? I've seen this. So if you just end up dropping your coins into that, the maximum coins that you can get is the maximum height it can go, and the maximum area each coin can gain is the maximum area of it. Please, guys, get my idea, or I can simply just tell you this. You guys drink water, you take your glass, your tumbler. If you pour your water into that, what do you guys get? Get the water is risen to the height of the tumbler. Anything that goes beyond that height, it spills out. Right? So what happens here is the water is currently occupying certain area which is equal to the area of base, and it is occupying the total length of the tumbler. Total height multiplied by base, that will be its volume. Volume is that. Now, starting with this, I have my first case. I have my now. For this, I have already written each and everything. I won't just writing everything. I will be rather explaining it to you. So, starting with this, I have my cuboid. Cuboids are what? Are when you arrange six rectangles in such a way that opposite faces have the same dimensions. If I take this, what I truly the thing that I told you earlier, if you take two triangles which are congruent, rectangles which are congruent to each, let's say I put them at my top face and my bottom face, right? They must share the same common dimensions. Let's say if its height is L, bottom face must be having an L as its length, but height is length. Now, if top face has a breadth B, then the bottom face must be having a breadth, right? Now I do this. I just pick another pair of rectangles which shares the same common base. It has the same common length, which is but its height is h now. Right. Similarly, this will share the same common base b and a height h. Now this backside and front side, they both share the same common base l, a height h. What happens here is in every two opposite faces must share the same dimension. I take it here. Now you see, since we have to take rectangles, so let us assume their dimensions L being and h. Length being length, breadth being breadth, and height being h. What I do here, now you see here, I have how many vertices here? 1, 2, 3, 5, 6, 7, and 8. Now you have your 8 vertices, right? Now, how many faces does it have? You guys see, it has 6 faces. I've already told you. Don't have to count them even. Now, the case of edges, or I can say sides. Edges are in what? Edges are in its cubes only. There are sides in the case of cuboids. Now see how many sides are there. First side, third side, fourth side, fifth, sixth, seventh, eighth, ninth, 10th, and 12th. So you total have how many sides? You total have 12 sides. Although you have 6 faces, but two faces are actually 3 faces are sharing common sides. See, if you count this, this, and this, they are sharing this. Actually, that is the case. You get how many sides? So you get end up having this here. The front face must be congruent to back face. Left face must be congruent to right one, and top face. This is the case here. Now you guys look at this figure. You end up getting in every type of face. The top, this is the bottom. This is the front one here, this here. And the back one is the right face, it is blue. And this right must also. So get an idea how this is made here. This is a 3D figure. I cannot just pick it out. I cannot just point it to you which face is of which color, but I can tell you this. If top face is saffron, then the bottom face must be saffron. That means it will be sharing its exact properties mentioned. If my right face is blue, then my left face will also be blue. That means it will be sharing in every dimension as it is given. Now, if my front face is yellow, that means my back face will be yellow. What it truly means is the color means that it will be sharing the same dimensions as my front face, and my right and left will be sharing the same dimensions, and my top and bottom dimensions. The case here. I hope you guys have understood the case of now. I have to find derive the cuboidal formula, its surface area. So now you guys know its each side is it's congruent to the opposite face. If they both have, if I calculate the area of this face as a length and it has width, its area will be what? Width, right? Considering I have just written front face here, so I consider this one length and this one breadth and this height. But whatever you want, you can call them. If I consider this face, length into breadth, similarly your base area will be width. If you consider this face, you have a depth that will be height. Its area is what? Width. Its area, your left and one's areas will also width. Now come to your front and back. We have a length, we have height. That means area of yellow portion is what? LH, and the back one will also be LH. So you get what? LH, LH, LB, LB, and BH. You get this areas of 6 faces. Now you guys see here, front face LH, back face also, right face BH, left face BH, top face LB, and bottom face LB. You get this? Now you guys see here. Your front face is this, length into breadth, and length into height. The face, na, right? This is your front face. It is sharing the length and height. So LH, back one also LH, left one, right one, BH, BH, and top one, bottom one, LB, LB. So you get this, you get twice of LH, so you can say 2LH, right? You can say 2BH and you can say 2L. Taking 2 common, you have your total area, which is what? 2 into LB plus H plus. This is the total surface area of what? A cuboid. I have taken each and every face. That was the total surface area. Now, if the case of lateral surface area arises and somebody says to you to tell him or me the lateral surface area of that case. So, lateral surface area of cuboid is what? It is the area of four walls. You have to consider the four walls: front, left, right, and back. You have to consider these four. So you can simply say this: front face LH, back face LH. LH, right, left and right, 2BH, 2BH. So 2LH plus. Or simply you can do is take your total surface area, subtract the area of the faces that you do not. Now I knew in lateral surface area there is no surface area of top and bottom. Simply just subtracting from this to LB, I get what? I get this. You subtract this for you subtract this and this, you get PH plus 2 HL. Taking H common, I get this 2H into L plus. It is what? It is parameter of base multiplied by its height. Parameter of rectangle multiplied by height is your area of four walls. In mind, area of four walls or lateral surface area, it is the same thing. And just with relevance to this part, if there is mentioned to you that you are not taking certain kind of face, just remember this. You don't have to add its area. Just take that face out, remove its area from the total surface area, or you can do this. What? See, I will be explaining it. If there is mentioned to you that you don't have to take an area of a particular face, then you can do that in two methods. First one, the first method will be this. Guys, do this. Take your total surface area and remove the area of that face that you do not. If there is any face that you do not require, what you can do is take a total surface area and subtract of that face. That is the case. Or you can do it first. Or you can do is pick your lateral surface area or your curved surface area. That means pick the area of only walls. Pick that up and add the area of that face that you want extra from that. Let's say if I did not want this top face, what I could do is I could just subtract the surface area and the area of top. Like I could do this, or I could do this. It's lateral surface area plus area. Is the lateral surface area is area of four walls. Either I can add the area of extra face that I want, my lateral surface area, or remove the area of that face that I do not want, my total. These are the two possible conditions by which you can calculate area of any figure which is given to you that there are certain faces which we are not. Like I will be considering certain extra portions in this chapter. Firstly, you have to understand each and everything. You have to understand basics. So for this, in cuboid, opposite faces share the same dimensions. So that is the case, and each opposite face is sharing the same dimension. So you will be ending up having these. Adding those, you got a total area which was. Now it was given to you that you had to calculate the lateral surface area, and you guys knew lateral surface area was what? It was area excluding top and bottom. So had to subtract area of top and bottom from it area. Subtracting that, I got this, which parameter of rectangle multiplied by height, or you can say parameter of the base multiply its height. That is what? That is the actually I just cited the yeah, here. We will be considering its four walls of this one together multiplied with its height. You get what? Get the area of walls. Now you see, guys have to find out the dimensions of a cuboid. Have to find out the diagonal of the cuboid. How you guys will be doing it is just square rooting You guys remember your what? You guys remember Pythagoras, right? It is a 3D figure since, so your diagonal square will be what? Square of L square, square each and every side, and add them. That will give you the diagonal of void. Similarly, it will give you the diagonal of cube as well. Now, remember this. It is a 3D figure. I will give you the of this portion. This, but for now, remember this. The diagonal of cuboid is what? Diagonal of square root of L square, B square, and H square. Square of every side, adding them and square rooting them. That gives you what? That gives you the diagonal of a cuboid. I hope you guys have understood this. Now, coming to the concept of cube. Cube is what? Cube is any figure which shares six equal dimensions of squares. That means it has squares, six squares of each side. Its each and every face is congruent to each and every other face. It does not matter which face you are considering. In cube, each and every face shares the same dimension. Guys, see here. Now, if this is the case, so it does not matter which face you are considering. Top, bottom, left, right, front, back. Any face you pick up, it will be equal to any other face. See, if I pick this, my top face, it will equal to the back face. Also be back face. It will also equal to your left and right faces. It will also be bottom face. It does not matter which side you are picking, which face you are picking, it will be equal to any face. Like your cuboid, it also has six faces because we are taking how many squares? We are taking, it has six faces, it has eight vertices, and it has edges. It does not matter. Figures, the things will remain the same. Just the difference will be in the dimensions of both. Cuboid has every side different, has every side. Remember this? Cube has edges and that has sides. You can say vertices. Now, for this, you guys know its diagonal will be what? If you guys remember the formula of diagonal in the case, at this was L square H square. Since each and every side is equal, that means A square, A being your any side, so diagonal is what it is. B, right? This is the formula of diagonal by cuboid. You guys remember this? I've already told you in the case of square, my previous videos, that square has a diagonal of square. Okay? This has it. Now let's see. Now let's see how its formula is derived. Since cube shares six squares of equal dimension and area of square is what? Is a square. That means its area will be what? Six faces, area of each a square. Its area is what? Unit. But this is an area. It will be only in square units. Centimeter square or meter square or even kilometer square, whatever you want, it will remain in square powers. Lateral surface area is what? It is that area of a given figure which does not share any top or bottom face. I have to consider area of four walls of a cube. In that case, what you have to do is subtract the area of top and bottom face. 6a square minus 2a square. What you get? You get a 4a square. Area of four walls in case of cube is 4a square. You can simply say lateral surface area of a cube. But it is understood. Again, this case arises if you guys have to add an area of a particular face. Let's say it is given to you that I have a cuboid, cubical box. It is open from top. It does not have any top. You have to find its area. So you can do is what you can either subtract the area of top from your surface area, or you can do is what you can just take its lateral surface area and add the area bottom also, right? Because lateral surface area does not count any of its top or bottom faces. In that case, you will be adding the extra face that is remaining, or you can just subtract that face that you do not require from it. Cases will there be? First one, see, I can tell you this. Uh, if you guys have, let's just with that. Remember this, you guys have to do this like this. Now, let's start with the next case. I have a plastic box 1.5 meter long, 1.25 meter wide, and 5 centimeter deep. It is open at the top, ignoring the thickness of plastic sheet. Determine area of sheet required for making the box and the cost of sheet for it. The sheet measuring 1 meter square costs. Now it is given to you that I have a plastic box of dimensions 1.5 meter length, 1.25 meter breadth, and 65 centimeter depth. So that means it has three dimensions. A 3D figure. Now it is also given to you that it is a box, so you have to draw what? Its dimensions are different, so it okay. But our cuboid should be like this, right? If this is a cuboid and it is having a length of 1 meter and breadth of 1.25 meter and a height of 65 centimeters, what do I have to do? I have to find out the area of sheet required for making the box. It is not given to you that we are not considering any of the faces. That means what we have to do in first cases, we find out the surface area, then we have to find out the total cost. Right? It is easy, right? So you guys know length is what? It is 0.5 meter. Width is what? It is 1.25 meter. And its height is what? It is 5 centimeter. Now see your cost is in meter square. So either you can do this, convert it into meter, or you can convert this one into meter, or these one into centimeter. So I'm going with centimeter. 1 meter square, 1 meter has 100 meters, so that means 100 centimeter. So that means 1.5 meter will be what? Centimeter. 125 centimeter, and finally centimeter. Right? So its area will be what? Total surface area is what? Tell me which formula should I apply? Surface area. Yeah, it will be this formula. 2 into LB H L. That means 2 into 150 into 125 plus 65 into 125 plus 150 LB H L. All this, whatever you get here, that will be area. Let's see. 125 and 1. Let me just quickly calculate this for you. 1875. Then 5 into 125, it will be what? 125. And then you have 150, a 9750. Add those 9750 plus 8125 and 1875. Get what? You get this 2 into 36625. That is, now you have to multiply it with 2. Get what? You get this 7350. Yep. So your area is what now? It is 73250 centimeters square. Now you guys see, it is given to me that the cost of 1 meter square is 20. That means cost of 1 meter square, this is 20. That means that 1 meter square has what? 1 meter is equal to, write it for you. 1 meter equals to 100 centimeter. You have to square it. And this one also, you get what? 10,000 centimeter. 10,000 centimeter square is what? 20. 1 centimeter square is what? 1. 10,000. Now you have what? Just 73250 centimeter square. It will be 10,000 into 73. Whatever you get here, that will be your constant. Let me tell you again. It was given to you that there was a plastic box of dimensions. You had it. Sorry, we did wrong. Some. I got this. It is opened at the top. It is given to you that it is opened at the top. Let me just draw it again. I just did it here. Yeah, it wasn't having any top. So in that case, what I will be is my TSA was what? It was 2 into LB plus BH plus HL. I wasn't required any top, so that means I have to subtract a BL from it. Now I know my values are these. Now you have to do what? Uh, let's just do it again. 2 into L is what? 1.5 into 1.5 plus 1.25 into 0.65. I'm just going for meter plus 0.65 into what? 1 point. That is the case. I have to subtract what? I have to subtract 1.5 into 1.5 here also. Solve this. Let's see what we get here. Get this 0.875 plus 0.81. You can do the calculations, right? Continue this, do the calculation on your own. Then you have to do what? You have been given cost of 1 meter square is 20. Just whatever you have here, multiply that term with what? See, your answer. Right? I will do the next one. Yeah, I will not be using calculator. The length, breadth, and height of a room are 5 meter, 4 meter, and 3 meter respectively. Find the cost of whitewashing the walls of the room and the ceiling. Remember this? We are whitewashing walls and the ceiling. Ceiling means the top one where we hang our fans. Guys, right? Know this? If this is the case, let me just draw my room here first. My room must be a cuboid. A cuboid. Now I have to paint this. I have to paint this, that, and I have to paint that one and this one. But I don't have to paint as. Let me just sit here. Yeah, I don't need to paint this one. This one is excluded. I don't need that one. That piece. I know this. What I can do here is, if my dimensions are my length is 5 meter, my width is 4 meter, and my height is 3 meter, I don't have to paint that bottom face, so I can do this. Total surface area minus area of base, what is my required area, right? It was given to you that you are going to paint the four walls and the ceiling, but you are not going to paint as your floor. See, we are not painting our floors. It was given to us. It was obvious to us that we won't be painting at our floors. So in that case, I will be doing what? I can either subtract my area of base from total surface area, or I can do it like this. Area of four walls, or you can say LSA plus area of top. Either you can do it like this or you can do it like this. That is totally your choice. Using of four walls is fixed. I will be painting four of them, but I won't be doing is I won't be any base. Either I can subtract the area of base to my total surface area, or I can just add the area of top to my lateral surface. Any method that you want, you can apply that. I prefer this one to be. I don't have to do much calculation. I will be doing what? I will be adding the area of top to my lateral surface. It is pretty. Now, for this, I know area of four walls or LSA squared is what? It is 2 into that means parameter of rectangle 2 into L plus B times height. Like length is 5, breadth is 4. Is always remember this, the longest side is your length, second longest is your breadth, and shortest one is the case 2 into 9. Okay, so that means 6 into 9. You get what? You get a 50 meter square, right? That is the area of four walls. I have to find the area of top 2. Area of top is what? Right? That means 5 into 4. 20. So your total area be painted. What? 4 plus 20. You get 4 meter square. So your total area to be painted is 74. Now, cost per meter square was cost of 1 meter square painting was 0.50. That means 74 meters square will 7.50 74. Bring this out, 37 and a 5 here, 3 here, into now whatever you get here, that will be your answer. Right? It was given to you that the room's dimensions were 5, 4, and 3 respectively, and it was also mentioned to you that the length was the length was 5, the breadth was 4, and the height was 3. Always remember this. If it is given to you, then you have to follow that sequence. If it is not given to you, just know this: the longest side will be your length, the second longest will be your breadth, and the shortest one will be your height. Always take them in this order, unless or until it is being mentioned. Calculate them, whatever you get, that will be your answer. See, firstly, what we did, we found out the parameter of rectangle. It was 5 plus 4 multiplied by 3. That would have been 6 into 9. It was, and the area of top was 4 into 5. That was 20. Adding both of them, you got 74. Now, cost of 1 meter square was 7.5, and the cost of 74 meter square will be what? 7.5 into, solving that, I got this 50 into 37. Solve this, whatever you get, that will be your answer. I can write 37 to be this 40 minus 3, let's say 15 into 40 minus. Now, guys, see, this will be what? It will give you a 600, right? First 15 plus 60 and a 0 minus 5. Solve this, you will be getting a 5 and a 5, a 5. Right? That will be the answer. I hope you guys have understood this. If there is any calculation error, do let me know, or you can just correct it on your and then let me know as well. Now, let's see our next sum. I have this sum now. The floor of a rectangular hall has a parameter of 250. If the cost of painting the four walls at a rate of 10 per meter square is 15,000, find the height of the. I have this figure. I have a rectangular hall. Let's say it is this. If it is this, and it is given to you that the area of the the parameter of the floor, that means the length of its edges, its boundary, but it is 2. That means 2 into L plus B is what it is, 250 meter, and it is also given to you that the total cost of painting four walls, it is what, four walls at the rate of rupees 10 per meter square is what, is 15,000. So that means uh 10 per meter square cost this. That means total area will be total cost divided by per meter square cost, right? So that means 1000 divided by 10. So you get what? Right? Guess what? So the total area of four walls which was to be painted is 100 meter square. Sorry, it is 1500 meter square. Right? Now I know area of four walls is what? 2 into L plus B. That means parameter of a rectangle multiplied. Right? Right? I know parameter of rectangle is what? Now I can say this. Using everything else, I want to know 2 into L plus B was what? I knew 250 multiplied by H will be what? Of four walls, which was what? Which 100. Height will be what? 100 divided by, cancelling this. You get a 5, 3, 6, get a meter. The height of wall was what? It was meter. Let me repeat it to you. The floor of a rectangular hall had a parameter of 2 meter. If the cost of painting the walls at a rate of 10 per meter square is 50,000, find the height of the hall. It was given to you that the four walls of that hall were to be painted. The four walls were to be painted. Had to paint only walls. Now I knew its parameter. The parameter of the base was 250. I knew the area of 4 wall is parameter of rectangle, parameter of base multiplied by its height. I had to find its height. I knew its parameter was 2 into h will be what? It will be my total area. And I knew total area multiplied by 10 gave me a 15,000. That was the total cost of painting 4. If I had to find out its total area, what it actually was, what I will be doing is I will be dividing my total cost by per meter square cost. Dividing that, I got my area, which was 100 meter square. 50 into h is what? 100 meters. H will be what? 1500 divided by 250. Solve that, you will be getting a height, which is 6 meters. Right? Now, next case.